Okay, hello. We are live. Really excited to kick off this episode today. We have Dima, CTO of Fireworks. I'll allow him to introduce himself and his background. But the background that I have is that we actually run the same team in ICPC back in the day, where I was sadly way worse than Dima. But I'll let him introduce himself.
Yeah, thanks, Illia. Super excited to be here. And yeah, as Illia mentioned, we kind of actually all three of us go way back through programming competitions. So I've been on the same team with Illia in the same school, and with Alex, I think we were competing against each other on many different programming competitions. So that's been fun. But yeah, I am now founder of and CTO of Fireworks, and we're gonna, I guess, talk a lot about AI and Fireworks and what we do. Before that, I was many years working kind of AI infrastructure, AI platform space over at Meta. Particularly for the past 5 years, for the last 5 years there, I was one of the 4 core maintainers of PyTorch. So kind of we went from early humble beginnings in research to adoption everywhere. I know, Illia, you were in early days of TensorFlow a little bit, so sorry. But yeah.
Sorry you won. Sorry, but no sorry.
Sorry, no. Jax is great. But so that's been a fun journey of kind of bringing AI to the masses and productionization of deep learning kind of across Meta products and across the industry. And kind of with Fireworks, it's kind of continuation of that, but now with the generative AI large language models wave.
Awesome. Yeah. So I guess, we talk a lot about open source and user-owned AI. And so the kind of exciting part, obviously, been we've been using Fireworks for open source models, and it's been really good experience. So do you want to introduce kind of what Fireworks offers, how you guys view the space overall, and what you're trying to achieve?
Yeah, of course. So generally Fireworks is like a platform for building with generative AI, or like with foundational models like large language models or image generation, etc. Targeted at developers or businesses, starting with just inference of open source models, but also all the different things, including customization of deployments, customization of models, fine-tuning, and various building blocks which you might need to actually build an application end-to-end. And as you touched on it, my personal background is a lot with kind of open source and open science through like PyTorch and related things. And like what we really believe is that like open weights models, like open source models, they already have pretty big footprint in the industry and kind of in the usage, but that footprint will even grow over time, and I can expand why we believe so. Our bet overall is basically to be the best platform for building this generative AI with open weights models to allow developers and businesses to customize and tailor for their needs and build end-to-end applications which they can control, and they can take from small developer phase all the way to like production scaling and kind of enterprise scale. But specifically on open source part, I think there is this kind of big kind of two ways of philosophy, right? Like kind of two ways how the space is developing. On one side, there are frontier models built by frontier labs, GPT from OpenAI, Claude from Anthropic, some other models from various some Chinese labs, etc. Like all of those models, they're great, right? But they are fundamentally aiming on building the biggest and greatest and most awesome model for absolutely all use cases, kind of trying to aim at AGI, which is great for a lot of use cases, especially like some of the consumer applications, kind of an arbitrary like ChatGPT conversation. But then if you look at kind of a lot of applications and businesses and concrete stuff, several problems emerge. One, you actually don't necessarily need the biggest and mightiest model, which is good at all use cases, because majority of use cases are more narrow or more specialized. If you're trying to build some customer support assistant, you actually explicitly don't want that assistant to chat with you about all the possible Pokemon types or write you poems, etc. You actually want it to stay on message. So you don't want all those capabilities. You actually want to have control over quality in relatively narrow domain. And as a consequence, you actually often want to have lower cost and maybe like higher performance characteristics, which are achievable with tailoring for this particular use case, maybe using smaller models or serving it in a different way, which is specialized for this use case. So yeah, all these factors kind of push use cases in business more towards beam control and customization for their needs, which fundamentally means starting with open weights, so you have control of what you're running, and have ability as use case graduates to be able to go and poke into it and customize it and build it further. So that's one motivation. Another motivation which we hear a lot from our customers is just being in control of your own destiny. So you all seen threads on Twitter like, oh, my ChatGPT got dumber or got smarter or whatever. People are really kind of worried about that, so they actually want to know which version of the model they run, and they want to be in control, not kind of some external API provider, even if that's great. So all these reasons like control and the ability to customize and optimizing cost and performance characteristics and improving quality in narrow domain kind of factors which push a lot of use cases towards open weights models. So the pattern which we often see is that people start with Claude or GPT-4 to kind of prototype and prove that the application is working, and as it's getting more scale or needs to specialize and needs to focus on costs, they kind of reach out for open models, which is great. And now you can ask like, hey, why do you need actually Fireworks? Because you can also go and like run LLAMA CPP on your 4090, etc., which is great for kind of enthusiast use case. But as you probably guys know from building infrastructure, whether it's for AI or for crypto, like infrastructure is hard, specifically for AI, like GPUs and accelerators generally tend to break, and even just babysitting them is not fun. Models change all the time, so you want to optimize those models for performance. You want to make sure that they are tailored to your use case. If something breaks, somebody is on call. Even just this basic layer, people run into problems with that. So that's something which we can provide. And as you kind of go further, there's both customizations needed on performance side of things. Maybe you have real-time voice application where latency is like super important for you. Maybe you bulk process PDFs and throughput is really important. Or if you are actually trying to build like assistant applications, etc., you don't just need the model inference. You also want to probably have some grounding like RAG. You want to have some maybe interface with external stuff, so we can talk about those kind of application components further on. So our goal is to basically take care of all this like hard but fundamentally boring stuff for application developer, like stuff which should just work, and like allow customers to actually build with AI and like focus on quality and enabling their application while they take care of all this kind of underlying platform stuff. Okay, that's a short pitch.
Yeah, shortish. Yeah. As a customer of Fireworks, I can assure that it's extremely fast. Maybe definitely one of the two fastest we know, but as we all know, one of them might not be future-proof. Without naming names.
Starts with G, ends with Q.
Starts with G, ends with Q, yes, but...
Rhymes with Elon Musk's model, right?
Yes.
We kind of pride ourselves to being the fastest or one of the fastest, as you say, in those applications. Not getting into details, like I would just, as a high level, the space for for Gen AI models inference, and specifically for like LLMs, is pretty kind of multidimensional and complicated. Fundamental reason for that is that those models are autoregressive, so they actually don't map that well to kind of GPUs accelerators, and there are a lot of tricks you need to do to make them run fast enough. So short of like some fundamental algorithmic advances, there is a lot of work to do on performance optimization side, which is, I guess, good and bad news. But the factors which kind of impact your performance, right? There is obviously all the various hardware choices, and we can go and bash about different like ASICs and GPUs and etc. That's pretty dynamic and fun space. But also just even from application use case perspective, there's like a lot of factors which kind of impact performance, whether you have long prompt or short prompt, which load level you care about, etc., etc. So you were mentioning some other of our competitors, and yeah, they're doing a great job in some workload use cases. For example, if you have like super short prompt and short generation, you can like respond super fast. What we see, for example, is that majority of production use cases actually do like grounding through regular like big system prompts. So actually have like super long prompts, which sometimes might be repeatable, etc. And yeah, in those cases, we are often like multiple times faster, which what you would get from competitors. Again, like optimizing all the levels of the stack from CUDA kernels all the way to how the service is deployed, just a tailor for like workload characteristics and generally be faster. And yeah, and to be clear, I mean, we've been doing a lot of like our founding team kind of comes from Google and Meta, and we've been doing a lot of AI platform optimizations for many years, myself included. So we kind of bring this experience to building customized our own stack. So we basically wrote our own inference engine from the ground up. So we are fully kind of in control, and we are able to tune and customize it, post for latest models for use cases.
So I have a couple of interesting questions going into the weeds of some of the offerings. So we happened to spend a lot of time a couple of weeks ago playing with the different instantiations of LLAMA. And LLAMA is notorious for having a relatively short context compared to, say, Mistral. But Mistral is not as good, right? So like you're choosing between quality and the context length, and quality, like in some cases, the quality of Mistral is just not sufficient, right? So you're sort of forced into shorter context, right? And however, you guys do have a long context LLAMA. So I guess one interesting question is, generally, like if you look at the models that Fireworks has, it has a long context LLAMA, it has a fire functions, right? How do you generally approach creating those custom models? Where do you get data? Is it like synthetic data? Are you annotating that data? Is it some open source data sets that are available for such use cases?
Yeah. So yeah, I mean, okay. So let me answer the long context part, and then maybe go to kind of how we train some of the models which we ourselves fine tune. So on long context part, we actually published a blog post maybe like last month, kind of just evaluating a lot of long context models. I mean, the sad part is that they're actually not that many. I mean, like there are not that many like open weights models right now which are like really good at long context. And let me clarify what I mean by that. Is I think like long context is generally super overloaded, and it's pretty hard to measure. You've seen probably a lot of these charts of needle in haystack floating around on Twitter, which they do like very basic stuff, right? They take like, I don't know, they take a book, they take like a long book, stick it in the context, and put like some absolutely random sentence in the middle, like, I don't know, how many lollipops does the unicorn have, or something like this, and ask a question at the end. It's like, oh, how many lollipops do like the sentence was like, I don't know, unicorns have 7 lollipops or something, and they ask this question at the very end, and kind of if the model can retrieve it, then they say it's great, which is actually like pretty simple test, right? Because if you have attention, as Illia can tell you, right, from early days, right, like this unicorn probably never appears in that book anyway, so it's super easy to like find that sentence and just pull out the right thing for the model. But this is not usually what you want, right? Like you want instruction following over the long context window. You want kind of some reasoning abilities, etc. And the more kind of sophisticated you make the tests, the faster the models kind of fall off from there. So even for like GPT and Claude, like once you start pushing kind of past like 64K context window or like 32K window, it gets a little bit icky. I think one good, there was a good paper, then they were like into like ruler benchmark. They had like a bunch of tasks which are like more complicated, but basically come to the point of if there are multiple, if you, instead of asking model to just like retrieve a single sentence, either try to come up with a benchmark which actually requires understanding broader text, or at least have like a bits and pieces of the same story splattered around a big text, right? So instead of asking just about unicorns, it inserts sentences somewhere like, oh, Mary went to the kitchen, and then like somewhere later picking up from that story, or like she took something from the stove or whatever, and like try to splatter that story in and ask about kind of multi-step reasoning, and then like a lot of models drop off from quality. So we like evaluated a lot of open source models, and sadly, the quality actually drops off even for many models which do claim to be kind of super good in long context. They on more complicated tasks, they often fall off. We try to do our own kind of a little bit of fine-tuning for that. But frankly, it's really hard to get super good results, something which you actually want to like for robust production usage, precisely because it requires a lot of, there are two problems. Like one, you actually need like high quality training data for long context, like which incentivizes model to long context, because a lot of kind of documents and paragraphs are pretty short by themselves. Second problem, if you're trying to fine-tune something like LLAMA, then like LLAMA Instruct actually had very good like supervised fine-tuning data set for instruction following, which they did. I think from the paper is like 10 million tokens and like super high quality curated. So it's actually very easy to screw that up and basically make the model forget, like by doing something else.
Undo instructions.
Undo instruction following kind of on that part. So that's pretty tricky. So while we have a variety of offerings, and you should try various models. I mean, some of the EE models actually do pretty, like I think EE and like now DeepSeek are actually doing, I would say like from available open source models actually doing pretty well on like long context. I am hoping that, the rumor has it like LLAMA eventually will also release officially tuned long context window. I think for actual usage like that is kind of required. In the meantime, you're welcome to approximate this, but your mileage will vary depending on tried by various different models and platform, but your mileage might vary depending on the task. If it's simpler, it might work. If it's harder task, it might disintegrate. But your second question.
It would be nice to have that high quality instruction fine-tuning, so you can fine-tune the longer.
We're trying to build that, but it's partially it's really hard to get to like exactly that quality what you are getting from frontier models. Like I would say, if you guys want to collaborate on that would be pretty awesome. Second part of which where we had I guess like more success so far was like function calling fine-tuning. So you mentioned fire function. So we actually spent kind of multiple months. It's like our second iteration of the model, which we just released like in June, fire function v2. But the idea is basically to kind of produce the best model as a kind of base building blocks for kind of compound applications centered around function calling, for example, for like chatbots, which can do different actions, etc. So for folks who are like, who are not familiar with like function calling, it originally was popularized by OpenAI, but the idea is that like you train the model to kind of like translate user requests into some API calls or like some tool invocations, which it's aware of, kind of execute them in the background. So in some examples, actually execute this in the background, gets the result of the function call back to the user, back to the model, and model can decide to do further function calls or actually summarize the result and return it back to the user. This is very useful for kind of just like routing requests or kind of any kind of support agents type of stuff, because you effectively like translating between structured world of like APIs, DBs, and kind of interacting with software system and natural language which users want to chat. So for example, if you have like some, I guess, hello world example for that is, hey, can you please plot me the stock prices of top cloud providers, right? The model needs to figure out first what are the top cloud providers. Maybe it knows it. It needs to go call some API to as the latest stock price, and maybe go call some API to plot the resulting graph. So we have, like, as an example case, so maybe it's booking some flights or retrieving some information, so whatever. But yeah, that's generally function calling, and situation is kind of similar with long context, as you mentioned. There are a lot of if you go to Hugging Face, there's a ton of models fine-tuned for function calling. They all claim to do great, but devil is in details. A lot of what people try to fine-tune for is like single function call, which is basically just structured data extraction. I have a query, I want to convert it to JSON. That's often not, like, we actually started with that, but what we heard a lot from customers, like, that's not actually what they want for many cases. For many cases, what they want is, as I said, like kind of like customer support type of use case, where you want a little bit of general chattiness and helpiness, right? You still wanted to say, like, hey, if somebody says, hey, how are you? Like, still respond to it normally, not spit out a bunch of JSON, like user request, hello, status, okay, or whatever. So you still want to preserve a bunch of chattiness, but you want to have this like robust intent detection and conversion to like structured backend requests when needed. And finding this balance is actually pretty tricky. So that's a lot of what our focus with Fire Function was, how to balance like general chattiness and kind of intent detection when actually there needs to be some request made on the backend to satisfy the user question. Second is like doing multi-stage, like kind of parallel, like nested function calls. So if you need to do a chain of actions, how to do that well. And yeah, like from our evaluations, I think we're doing better than the majority of like kind of open weights models, and kind of on, again, all benchmarks are conditional, but like on kind of mix of public benchmarks people use, it's doing on par with like GPT-4o for like simple conversations. So that's been like a super fun journey into kind of how to do this fine tuning, etc. And by the way, the model is obviously available on the platform, running really fast, but the actual, like, it's open weights, so the weights are available on Hugging Face as well. So you are welcome to run it elsewhere, even though you shouldn't. But to your question, Alex, about like how to train, like what was the cooking process? It's based on LLAMA instruct. So we kind of have this like baseline chattiness already built in. So yeah, as always, the secret is in curating good fine-tuning data sets. So it's a combination of kind of synthetically generated data with other models. So you can you basically write a bunch of code to generate synthetic scenarios with multiple steps and multiple types of actions, multiple types of user requests. Function calling, it's relatively simpler because it's basically, if you can source representative set of like possible functions to call, just like open API specs, etc., you can ask like big models to kind of generate you plausible scenarios of how to call these functions, and then generate you kind of possible requests which could have generated this, and kind of come up with this very structured kind of multi-turn user interactions, which do translate into some API calls, which the model needs to do. And then there is like a tricky balance to kind of see where it starts overfitting to just calling the functions and generate enough data, which you can actually generate from the model itself. Generate enough data on just conversational side, so it doesn't kind of forget just broad instruction following. And if there is like retrieval of base knowledge of the world, the model is still capable of like answering for that. So that's kind of broadly speaking, kind of, yeah. So it's like synthetic. It's mostly synthetic pipeline from this kind of two sources, but actually like getting it right requires a lot of iteration. So as you guys probably doing yourself, because I know you fine-tuning some of the models too. Yeah, you kind of like curated the set and you look at like what's there, what the distributions are. You try to train. You play with the model. You do it well. So you see what in which scenarios it works worse. You try to augment your data pipeline with those scenarios. You make sure that like it didn't break other generations along the way. So even just like looking at your data set all the time is very helpful. And yeah, you kind of like rinse and repeat until you get to the good quality. I mean, the benefit of actually doing fine tuning is that yeah, you can do it on a pretty high frequency, and because this is not a pre-training run where you have to like YOLO and hope, you can actually kind of do it iteratively and improve quality along the way without worrying that, like, oh, I fired up all my GPUs for 3 months and ended up with some garbage.
Is Fire Functions a LoRa?
Sorry?
Is it the LoRa, Fire Functions?
So we tried both like LoRa and non-LoRa fine-tune. Actually, for this case, like quality is about the same. So yeah, it's like LoRa fine-tune, but we serve it like both merged and unmerged. But it's like pretty high rank.
You had the question, I interrupted you, right?
No, I just said YOLO and Prey.
Yeah, YOLO and Prey. Well,
The
that's a game for pre-training.
Yeah.
Post-training and fine-tuning is a little bit more controllable.
Yeah, I guess maybe changing topic a little bit, given I think our audience is interested in more combination of where this approach is, open source in general, and as well crypto, decentralization, blockchains intersect. Maybe switching gears a little bit on how do you think, like, as this is evolving, right? Let's say we're gonna, we potentially have a LLAMA 400B finishing training, right, any day soon, and then let's say they decide not to open source it, right? I'm curious, kind of, given you're coming from a different perspective, like what do you think is kind of future for open weight and ideally actual open source models, and do you see the opportunity where kind of the approach we're taking, right? Like how can we coordinate a decentralized community of people to come together? And obviously there's a lot of technical challenges, there's a lot of kind of financial like questions as well, but do you think there is an opportunity for having like reasonably competitive solution, assuming a benefactor and your previous employer decides to not open source the next generation? I mean, hopefully they will, and like this is probably for next year. But
yeah, I don't know for sure, of course, because I'm not affiliated anymore. But from all the rumors I heard that it's imminent and happening next week.
I'm just saying, like, let's imagine it. Like, let's imagine they decide not to, right?
I mean, first of all, I really hope that that incentives in the long run are such that open weights community will continue to strive, and kind of Meta will continue to be the kind of one of the leaders there. And I mean, frankly, so far it seems that all the pointers are to the fact that it will not change, which is great. I think generally there is like enough incentives for people to like open source broadly, right? Especially for like companies for Meta, like Meta, who is like don't have kind of direct business benefit from keeping the model closed and building products on that. Like, I mean, they have user base, they're gonna build products with that anyway, right? But there's a kind of incentive from open source, like just from general advance in science to kind of commoditizing this space broadly, to kind of future-proofing and kind of like red teaming, if you will, from the community, which I think worked pretty well so far. People build people building a bunch of research and kind of building a bunch of experimentation on top, kind of fostering community and then benefiting from this community. I've seen this firsthand from like working on PyTorch, right? Like why the heck to open source PyTorch and pour resources into it, and especially just like purely on open source side. But I think that benefited Meta a lot by bringing back like all the innovation, or just like by making it like standard, which everybody uses. So you can use libraries built by other people. You can hire people who already know kind of PyTorch, etc. So it just like future-proofs your technology because people take it in so many different directions before maybe you explore those directions. I think the same is true for like foundational models, and that's the reason why Meta has been open sourcing. I mean, it's actually pretty good. We saw very capable models coming from some of the Chinese labs as well for the past year. So,
but I guess like
DeepSeek, etc. So I think like first of all, I don't think the space will disappear. To your crypto part, I mean, I would be very curious. Like, I mean, you guys are experts in this. Like, is there a way to like tie it up with financial incentives somehow? In like, is there a way to open source something but bring back some royalties or like some kind of financial incentives to the model provider? Frankly, I haven't seen like very viable kind of use case for that so far, because like these models are big. You will not put the whole model on chain, and there are still incentives to just like copy the weights and run it on your own. So that's kind of tricky. For really big models, there might be some way to structure this. We also work with some like model providers in like partnership form. And for example, we like serve like Stable Diffusion 3. So if you call their API, it actually goes to our servers, kind of behind the hood. And maybe there is like a setup of like doing it licensing wise. If it's really big models, people don't really gonna run it locally on their computers because it will not fit. For example, if it's like for 100B for like synthetic data generation or whatever, maybe there is like some way where you can craft the license and incentive such a way that you like work with a bunch of kind of hosted providers which offer it as an API, and there is some like rev share deal or whatever, and that incentivizes kind of model builders while still kind of like having open weights for like poking around and debugging, but not like industrial use, whatever. And if it's big enough, then probably people not gonna do it industrial use locally anyway. Maybe there is like some way to craft it license-wise. I don't know. Yeah, frankly, I don't know how to like put it in code or like put it on chain so it's like programmatically enforceable. But maybe some combination of like technology and careful license crafting might work out. I definitely see like some people experimenting with this with like interesting licenses where you need to buy some membership.
Well, stability was the first one, right?
Yeah, stability is the first one. Yeah, I don't know how it will work out in the long run. That's specifically on the model side. The part where I think it's much more plausible is like either like curating specialized data sets or kind of curating fine tunes and like model customizations, right? If you believe this world of like many small to medium models like tuned for different use cases, maybe there is some like marketplace dynamics to build here, right? If I have a use case for, basically if I'm a business and I have a use case for particular narrow domain, maybe I can have like some competition, Kaggle style, like some kind of way to like put this bid out and have various people try to come up with like a data set of fine-tune for this use case, and depending on how much that model gets used, get back some some compensation and financial incentives to those people. So you can kind of extrapolate it almost to the way of, hey, every time I'm using particular subset of the data set somehow through some model, like whoever builds the data set gets compensated. I know there are many folks kind of on intersection of AI and crypto community try to explore this space. So maybe something there. We haven't invested that much in this particular space. More focusing on like foundational infra space, but that I find kind of more plausible. On training, purely like pre-training, given how capital intensive it is, it's like unclear how you can crowd-fund it kind of explicitly, effectively, because you basically need to concentrate a lot of capital and buy those accelerators or GPUs and put them in put them in one data center and run for a while to do pre-training. So that becomes potentially harder. I know. What are your thoughts on this? Because I'm sure you guys are thinking about this a lot.
I think in terms of training, for any foreseeable future, it will all be happening in the big centralized clusters, right? So I think DeepMind has some interesting papers. I don't know how you pronounce them.
The second one came out. DeLoco, and there's a second one came out as well. It's pretty much bringing back. It's like you can parallelize over experts, right? So each expert can be on a different set of machines, and like they don't need to be as synced. And then you can have a pretty much parameter server approach where you have shared parameter servers that kind of everybody sends updates, and then you fetch new parameters, which is kind of how pre-TensorFlow training was happening. And so if you cook it right with all the right parameters, right, you can actually get something. It still requires reasonable connectivity and liveness of servers, but indeed has way lower requirements than the current setup where everything like wired up in the one script pretty much.
InfiniBand,
on InfiniBand, so there's, I think there's an interesting, and then the other thing is, if you assume that a lot more work is actually going to start happening on distilling models and like creating synthetic data and doing chain of thought unrolls and like a lot more training going into that, I think there can be an opportunity using a more distributed compute to do that, even if you're like exact training updates are happening on a smaller cluster. Again, by smaller cluster, it's still like few thousand, H100s, not, but at least you don't need like a 20,000 cluster.
What we call a small cluster was something that 5 years ago was the biggest cluster.
It was like GPT-2 trained on like basically one A100, like 8.
GPT-2 was trained on one machine with 8 A100s.
It's like the GX1 or whatever original. So.
It probably was V100s, right? Given how long ago it was.
I trained first transformer on CPU, so doing translation. So it's all relative.
But I definitely agree that like you kind of want to. It's more plausible for like data curation or specialized models, so like maybe like synthetic data generation, because it's more parallelizable. The actual training is harder. But if a lot of focus actually goes, if a lot of cooking happens in post-training these days, right? Which is not as compute intensive. So, and as you said, like curating data for post-training is like more expensive even compute-wise than actual training run. So that becomes more plausible and parallelizable, and how to set up incentives for that is interesting. But at least it's more plausible, because straightforward trying to parallelize just the train, like SGD updates itself. I feel like federated learning space kind of tried this a lot in like edge setting, and frankly, it had very, very like mild success so far. Just because it's hard to it's hard to parallelize core algorithm that well.
I don't think actually the problem was, I don't think it was because it was hard. It's because nobody needed it. That's honestly like, you can do it all on your data in your data center and experiment a ton, or you like deploy this multi-tenant setup, right, which you have no logging and no ability to debug, and like hope it works, right? That's kind of like, why would you do that to yourself, right?
And then you try to I think the only motivation was like regulators, but then explain.
Well, exactly. But
explaining
the only like production.
Sending PAI is bad, but sending gradients of PAI is fine. I think that was challenging too, but
So we'll see. This is actually the interesting question that I was thinking about, because I was asked by few people around Indeed PI. Let's say you are one of those big companies with a big chat app, right? Or whatever, right? And you are actually capturing a lot of the data from people using the app. Can you train on that? Because if you train on that and all that PII data actually, goes into the weights, and then you use and then people use it and be able to query it out, that's a very bad situation, right? So, and Google traditionally does a lot of cleaning for PII from Google search queries, because people keep putting like addresses and phone numbers and all kinds of stuff into search bar, even before it hits like kind of storage. But obviously, like with more sophisticated queries, like it becomes more complicated. But this is a good question. Can we actually detect PII based on like the log likelihood pretty much of the model, and being able to filter it out, or even better, predict it inside the gradient update, and kind of in some way avoid it. And this is like in general the topic I've been, I don't know, kind of thinking about it is how do we improve kind of the update function, because obviously the current gradient update is, it's either, you know, like go in that direction but a little bit, right, or like, well, shit we overstepped, let's go back, right? That's kind of like it doesn't have the nuance of, hey, like there's some facts here that we should remember, and you know, the rest is kind of just, you know, general, like let's know the syntax type thing. Or hey, you know, you're reading an article and there, at the end there's an author, like you will not be able to predict an author from the article, right? That's highly unlikely. So stuff like this, like there's a lot of nuance around that. So how do we make it more nuanced, how we making updates to parameters?
Yeah, I mean, yeah, that's exciting. I think, yeah, it's still probably a little bit far out from figuring out something that works, because people barely understand how SGD works so far, right? There's exciting.
If only it was like 40 years or 50 years of it.
Yeah, exactly. Well, not at this scale. I think we kind of understand how to train perceptron pretty well. But yeah, yeah. So that's fun. But I mean, to your question about like PI and like prediction, I think again, like I think more and more what people are doing is more like pre-processing and like synthetic. I mean, you can call it data generation, or like basically cleaning with LLMs themselves, right? Because you can ask. I mean, you can train models to remove PI. You can train models to like rewrite stuff, and like rewriting and cleaning works really well. So yeah, to your example about Otter, maybe you can like restructure it so it's more useful. I mean, the rumor has it that like big labs basically, you know, for next generation models, like even that is like a lot of synthetic data, even for pre-training. But certainly for like kind of post-training, like fine-tuning, that's, I mean, that there isn't like spending time and like cleaning those data sets and making them like kind of robust and easier to predict, and making the models kind of remember facts in style by just like providing very high quality data definitely is like the trend of the last last year or two or so. And I mean that's kind of more plausible and debuggable than trying to cook something with SGD updates. Don't get me wrong, I would love to understand how the SGD works.
So far SGD every time wins, right? Every time you try to add more structure, SGD comes in like
on that level, but you can give the right input to SGD.
Yeah, I mean, I think, well, the other interesting topic I think you touched a little bit is like hardware. I guess right now I'm assuming most of the stuff you guys running are on NVIDIA. There's indeed alternative hardware, ASICs, and that either exist or people working on. There's, you know, all of this like transformer kind of hardwired. Kind of how are you looking at that market? How are you thinking about, you know, I'm sure you just like whenever it works, we'll just use it. But but I guess like obviously whoever produces them can offer like a inference on top of it themselves as a cloud. So how are you kind of thinking about that?
Yeah, I mean, so first of all, it's like very, very fun and dynamic space, right? The whole computer architecture was like semi-dead, like I think like for 2000s or whatever, where people were trying to optimize last 2% of branch prediction. And I mean, here first with GPUs and now with ASICs and all the different chips, there's explosion of various architectures, which is I just technically find super cool and interesting.
That's because I haven't been tracking crypto. Crypto been playing with hardware for a while now.
Yeah, I know. I mean, I think it's about parallel. There were like also wave of like regional. I mean, there was a wave of like regional ASICs for computer vision circa like 2015, and there are like, some like lessons to learn from this, I guess. Yeah. So I mean, first of all, I think, you know, in the short term, GPUs are great and versatile, right? And yeah, like NVIDIA is great and it works, and that's why their stock price is so crazy. That's why people keep buying it. I think for inference specifically, it's more plausible to do something different, right? Because there's like less flexibility. All this ASICs usually fail, and like, oh, we're gonna go change my model a little bit in research and nothing works. In inference, it happens a little bit less often. So I'm hopeful that it will pan out in like a few years time frame. I mean, there is also a story of AMD, which we're also looking at, and AMD is was also like one of our investors for like Series B, which is great, together with NVIDIA. And yeah, like I think I mean AMD got like, it's also GPU. I mean, they got good hardware, to be honest. Their software stack historically has been lagging a lot. They've come a long way, so it's now working. But I mean, there are gaps and misses, but it's in the working stage. When we started working with like AMD and PyTorch land circa like 2017, 2018, that was like very raw to say the least. Now it's getting better. So even on GPU market, it's great to have like plausible competition. And like, for example, for inference domain, yeah, they have, for example, more HBM than current generation. Like MI300 has more HBM than H100, which is great, and it's actually good for inference stuff. So in short term, that why I'm hopeful about. I think generally for startups kind of trying to do ASIC, it's like a crazy trade-off, right? Like you need to find,
like a gamble with the life.
It's a gamble with life, yeah, and you need to like find this like Goldilocks zone, right? Because on one end you can overfit a particular architecture. I'm sure crypto guys did this, right? Because there were like Bitcoin mining chips which couldn't do anything else. In AI space, you probably remember all these like 40 startups which were doing CNN inference circa like 2015, 2016, out of which I guess only 2 or 3 survived, because by the time that they taped out a chip which can run VGG really, really fast, the world moved out to ResNet and stuff like that. So it's really tricky to like not overfit a particular architecture, but also not go very broad and very general, because if you go very general, then you're effectively trying to beat NVIDIA in its game. You're basically trying to build a GPU, and yeah, NVIDIA AMD spend like a lot of years building good GPUs. It's really unlikely you're gonna do something better. So that's an interesting kind of trade-off. And yeah, some startups kind of try to get this right. I think like last one was just making the news from this space was like Edged, I think, which is still kind of like same trade-offs as it has compute, it has HBM, so it's kind of like generally similar architecture to the GPU broadly speaking, but way less programmable. So you have like less flexibility there, easier to build, more power efficient. So yeah, I mean, I would probably give like smaller chance than 50% for them to succeed, but it's still much greater than 0, which is awesome. And yeah, there are like other startups along the same line. And then you have this like generation of people who like bet on SRAM like crazy. I think Grok is one of them. I mean, like Cerebras, and I think Cerebras is kind of in the same category, more or less. But basically, they say that like, okay, we're gonna ditch HBM, this like moderately fast but really really big memory, which is gonna be bet on SRAM, which is basically on-chip registers, more or less, which is very very fast, right? So you have like insane memory bandwidth, but it's very limited in space, right? So I think Grok was saying that like one of their chips has like 130 megabytes of SRAM, like memory at all, like which is all SRAM, which is really like a gamble in terms of model, in terms of like model architectures and model popularity, because even if you try to serve Llama 70B, you can do the math how many chips you need to do that, just to load the model and serve one request, right? You need like hundreds of chips to just load it in SRAM. Yeah, your request will be like super fast, but like economics will work out only if you have ginormous amount of traffic coming to a single model. So in effect, you're kind of betting on the future of single model serving lots of use cases, and having this like basically half a data center dedicated to serving this model in super parallelized way with very good interconnect, which might very well be like a lot of use cases. But the world which we talked about a lot of specialized models and smaller models, etc. Like that world actually looks very different hardware-wise than 1,000 chip holding single model in SRAM and running it really, really fast. So it's actually like this open weights world looks different with a lot of customization, a lot of specialized models, and that's why you see Grok having like 2 or 3 models offered, right? Because that's the fundamental bottleneck. Just like the fixed cost is really high. So that's an interesting design point, and I think it rocks in some use cases. It doesn't do so well in other use cases, but it's good to have like diversity and kind of balance in the community. And then there are, of course, some startups which try to do completely kind of experimental architectures. I don't know, like analog computing or whatnot, like optical analog, etc. Like I think that's even.
Maybe we'll have models that only need -1, 0, and +1, and so
exactly. Maybe
everything's solved.
1.58 bits is all you need, and then you
exactly,
and then you can do something like that. I think that, like, I personally find that extremely exciting, but the chances of that succeeding are like pretty low because of this huge gravitational pull of like existing transformer architectures, which you really had some hand in helping to create, right? And like kind of it works well enough, so there's so much hardware and software and optimization kind of knowledge sunk into making it work. It's like really hard to pull out of this. Like a lot of people tried, a few years back, there were capsule networks, right? Now there's like Mambas and state space models, which are like a relatively small twist on that. And even those, like, even if you run on GPUs, you run into like software optimization problems. If you try something more extreme and sparsely connected or whatever, then you run into hardware problems. And just like effectively train at like foundational model scale with new architecture just to see whether it will then work if you feed trillions and tokens in. It just becomes like exponentially harder. It's hard enough to train it with existing architecture and GPUs. It's much harder if you're trying to innovate across multiple layers, which is, again, sad, I think, from exploration perspective, but
it's kind of like if we're stuck in local minima and there's actually like another architectures that over a hump, but we cannot get over that hump, kind of because like somebody needs to bet.
It's like evolutionary branch, right? It's like maybe we're like all dinosaurs and like being like all our models are like dinosaurs, right? And being like warm-blooded,
and we just need to.
It's much better, right? But like there needs to be something, some big cataclysm happen to explore the different branch. But I hope it doesn't.
I don't know.
But something.
I'm more of. I mean, obviously, I'm biased here, but my belief actually, like any big enough model has. Like with some inductive bias has the capability of learning anything, right? And it's more of a question how we're learning it versus like that's what I was saying. Like I think the fact that we don't understand how it's actually learning and kind of transitioning from like capability stages from one stage to another, like to me that's a problem. Not like, hey, we can go and like change the architecture. And like we pass now the information through this like vector instead of this vector. Like I feel like that's like not going to change fundamentally our understanding of how this model work, which I feel like requires for the next stage of innovation here. But I just wanted to make one comment for like crypto community, because notice how Dima outlined different trade-offs of different solutions and said it's great to have a competition and different people taking different approaches. In crypto, it would be like, no, my approach is the best and takes over all the use cases and everybody else is shit.
Well,
and Dima might be just polite.
I'm trying to be very diplomatic here. But no, I think it's like, I think generally community-wise, it's pretty, I mean, there's a first competition, but I think there is enough friendliness and cross-pollination.
I think there's just the market is growing so quickly that everybody's kind of figures out how, and so fast that everybody's figuring out how to all work together. I'm just like I just came from a crypto conference, so I'm my brain is still hardwired into those discussions.
But of course you should use only fireworks for your open weight models because they are the best.
I have a quick technical question. from the early discussion. You mentioned again that I guess it's sort of implicit, right? That Fireworks is betting on a lot of small fine-tuned llamas as a way to compete with the, like the world in which GPT-5 exists. I guess a question is, so let's say, let's use the example of like a support chat, right? In your experience, how many samples does it take for a customer to make a model sort of good at their use case? And are they, like, how good is synthetic data for this use case, right? So like, if I'm like a hypothetical company that wants to have intercom bot, like if I just use Llama 70B to generate, like 20,000 examples, will I get a decent model for my use case, or do I need more examples and do I need to involve humans?
I mean, it really depends on the use case, I would say, right? And how much effort how good are you at generating data? Just number-wise, I mean, like tens of thousands is fine, right? I mean, the more the merrier if it's high quality, of course. But again, depends on this. I mean, the way I think about it is like, if you can prompt engineer the foundational models into particular pattern with like multi-step prompt, etc., like you can basically compress this to fine-tuning, no question, right? Something more complicated, where you can't just prompt engineer it, since in requires more effort comparatively, because it's like harder for if model can't grasp when you tell it like in very verbose form to follow some instructions, it's harder to translate that knowledge into it's harder to make it work through the weights updates, because it's not just tuning the style a little bit. So then it requires more focus on maybe like more data and incorporating new knowledge or something like this. But yeah, it's definitely plausible. And what you also see is like usually people start building this big mighty model, and then they realize what's their product market fit is and what their bucket of use cases is, and they also already have some like real data from users they can train on, or they can use as a reference for generating some data. And that's where you have like much better idea of like what the typical interactions are, and you can kind of compress it into a smaller case. And like the more restrictive domain is, the better, right? Like for example, if customer support is harder, but for some like simpler like code completion cases, where like maybe latency is really important, but you don't want like perfect accuracy, like latency is all you want, that's like a clear-cut trade-off, like smaller model, fine-tuned, and you can like generate a lot of training data because it's just code which you're completing from interactions, right? That's like easier to fine-tune, for example, right? And then you have some of the customers kind of from coding assistance type of use cases which like do this kind of in their products, whether it's the Cursor or Source Graph, Cody, or etc. So I guess like really depends on use case. And going forward, I think like having more permissively licensed big models, so hopefully 400 VLANs this week, like next week, that makes game incrementally easier, which is awesome.
And you guys ready to have 400B on Fireworks right away, right?
Yeah, we hope we are. Yeah, we'll see.
I mean, you can just initialize a model with 400B.
Yeah.
We can serve it, right?
Yeah. So
just replace weights later.
Yeah. I guess I'm actually. I mean, we talked about long llama, but I mean, this is just like we probably can ask it in our Slack channel later. But you guys have the like sharded attention that can span multiple machines when you go for like a longer context.
Yeah. So I mean, basically, if you like, if you have multiple. So I mean, there are like two ways of like sharding attention, basically, right? You can do like regular tensor parallelism, like Megatron style, which for attention basically means that you split by head, right, across multiple GPUs, and that actually works fine for inference also in many cases. but there is like more communication between. I mean, like more blocking communication, both on like weight sides and on kind of if your context is long, then like on activations and like QV there. Another option is to kind of split by sequence lengths. I think in training this paper was called like ring attention, but it's like training equivalent of that, but it's basically like chunking the sequence lengths when you do prefill, like chunking the sequence lengths and passing on the like kind of preview like KV chunks in parallel with like how you compute them. So we have all the possible versions of parallelism implemented. Yeah, it really depends on like settings on like how big the prefills are and how big your prompts are, basically how like what the model is it MOE, etc. Like how proportionally heavy MLP versus attention is compute-wise, what's the like load level, etc. And there's like lots of knobs you can tune, which is what one of the things which we do really well, kind of like configuring, like finding the right configuration for particular use case. So if you come to us and say like, hey, I have this like real-time coding assistant, or I have this like voice support chatbot where I need that as much throughput as possible under this super tight latency constraint on this type of workload. Those are kind of type of knobs which we can do under the hood to kind of support you best, or tune a speculative decoding stuff, or like do some deployment configuration, etc. So list goes on and on and on, and that's kind of goes back to those are like some of the things why I was saying that even for open weights models, there's a lot of just pure, even before you touch into quality, there's a lot of just
parameters,
pure infra kind of setup needed, and like that can make huge difference both user experience wise because your stuff runs faster, and cost wise because your stuff runs the same traffic can run on fewer accelerators, so you pay less money fundamentally.
Makes sense. All right. Well, if folks want to learn more about Fireworks, it's fireworks.ai. And we will. Thanks, Dima, for coming and kind of having this great discussion. I hope it was interesting for everyone to learn more a little bit from a different side, right, on folks who are optimizing and kind of serving a bunch of clients across various areas. Thanks for joining, everyone, and we'll see you next time with more conversations.
Yeah, thank you, and happy to have NEAR as one of the customers, and looking forward to kind of work together on ways to connect maybe crypto and AI ecosystems, both technically and culture-wise. Cool.
Awesome.